Hey, good morning YouTube, Nicholas from Game Dev Maniacs here. Welcome to this 5th episode in the beginner series where we learned how to make a simple 2D action game from scratch called Showdown. So far in this series, we've been learning a lot about really important concepts such as variables to store and manipulate game data, conditionals to create logic and make decisions, as well as plenty of Pico instructions and the game loop. There's not a whole lot left for us to learn before we actually complete our first game. So in this video, we're going to be making the game a little bit more interactive by processing player input. And we'll be focusing on how to make the gameplay a little bit more fun for the player. Let's get started. So in Pico 8, a gamepad has 6 buttons. The directional buttons left, right, up, down, as well as 2 action buttons, which are the circle and the cross button. Pico 8 actually has support up to 2 controllers. As with the colors, Pico 8 has an associated number for each of these corresponding buttons. The button 0 is left, button 1 is right, button 2 is up, 3 is down, 4 is circle, and 5 is cross. So since Showdown is a single player game, we're going to focus about the single player experience for now. We could always be using a gamepad in Pico 8, but the platform also provides keyboard support. The keyboard layout for a single player game is typically as follows. A player will be using the arrow keys for the directions, Z for the circle, and X for the cross button. Hence, putting the number here for reference. Pico 8 provides 2 separate instructions to check whether the player is using a button on their gamepad. These are button and button P. Button checks whether a button is currently pressed or not. This can be very useful to track things like continuous motions or actions in the game. For example, we could be moving a character in the map anytime we're pressing a directional keys. In the code snippet that you're seeing here, we check for the button with index 2, which corresponds to the up button in the Pico 8 controller. And it can be triggered by pressing the up arrow key on your keyboard. This code means that anytime the up arrow key is being pressed, we would be printing the string up is currently pressed. By the way, something important to note is that the instruction btn or button already returns either true or false, depending on whether the button is being pressed or not. So there's no need for us to use a comparative operator here like equal equal, like what we did in the previous video when it's being used within the if instruction. The second instruction that Pico 8 provides to check whether a player is using the keyboard is button P, which stands for button pressed. Button P checks whether a key was pressed just recently, and it returns true if it was and false if it wasn't. This is very useful when you want to track single triggers like navigating through a menu options or firing a weapon. This is what we'll be using in our game. We want to know when the player is actually pulling the trigger during the duel. So let's move over back to our project and see how those 2 instructions can be used inside our game. So back into our game Showdown, we can see that the cloud is currently moving by itself. This is due to a manipulation that we did in the previous video. We are going to be changing this behavior to make it so that the player has control over the cloud. And when the player presses the X key on the keyboard, which corresponds to the button index number 5 for Pico 8, then we'll be moving the cloud. Let's go ahead and press escape twice to go inside our code. And we're going to locate the place where the cloud is being moved. If you recall, this is done within the update instruction, where we increase by 0.2 the horizontal position of the cloud automatically 30 times per second. We're going to change this and create a conditional here with an if statement, and we're going to check if the 5th button, which is the X key on the keyboard, is being pressed. This is done by the instruction if button 5, then we're just going to increase this by 1 and we're going to close our conditional here. So what this code says is that If the X key is pressed on the keyboard, then go ahead and increase the horizontal position of the cloud by 0.2. Let's go ahead and save and run our game. As you can see, by default, if I don't press anything on the keyboard, the cloud stays static because we're not going within this if condition. But if I start pressing the X key on my keyboard, you can see that the cloud starts moving. It stops moving as soon as I let go of the key. And this is because the button instruction checks whether the key is being pressed or not. Let's go ahead and swap that instruction for the button pressed instruction. Let's hit escape twice, and we're going to replace this button instruction with a button P instruction. Go ahead and save and run your game. Once again, the cloud is static, and as you start pressing repeatedly on your keyboard on the X key, you will see that the cloud starts moving. It's of course a lot slower because it's as if you're pulling the trigger on a gun. But every single time you press the X key on the keyboard, we enter this if condition, and then we are able to move the cloud position by 0.2. If you let the X key pressed, the cloud starts moving a little bit faster. And this is because the button P instruction actually resets every couple of frames. This is actually useful if you are using it to navigate within a menu or within a grid, for example. Alright, so here's the first challenge for you today. We are going to change the game so that the title, which currently scrolls down automatically, will only scroll down when the player is pressing the circle button. As a reminder, the circle button is currently mapped to the Z key on your keyboard. Go ahead and pause the video now and see if you can figure this one out. Alright, so back in our game, what we want to do is to make it so that the player controls how the title is scrolling. Let's go ahead and press the escape key twice and locate the place inside our code where the title is being scrolled. As you can see, it's just right above where we used to be. Right now, the only conditional means that title top needs to be smaller than 20 so that it continues scrolling. So one way that we can change this is to add an additional condition here. And remember that you can use multiple conditions as part of the same if statement. So we're going to check if the player is pressing the circle button, which corresponds to index number 4. And now if we save the game and run the game, our title is not moving. It's not scrolling down unless we press the Z key. And as we press the Z key, the title now scrolls down automatically. This is the solution to this challenge, and I hope you were able to figure it out. Now that we know how to process user input, it's time to give a little bit more control to the player over what's happening in the game. One very typical thing that is done in video games is to start the player inside some sort of title screen. This allows the player to indicate when they're actually ready to start playing the game. Once the player is ready to play, they'll either pick an option or they'll press a key, which is an event that we can catch and use to transition to the actual gameplay experience. By combining variables, conditionals, and player input, we can recreate this flow for the player. So this is what we're going to be doing now. We're going to be cleaning up our code a little bit and building a dedicated title scene. The title scene will be the first screen that the user will see, and it will contain several things that will make a nice presentation. First of all, we'll be scrolling the title down and bringing it roughly 40 pixels from the top, and then the title will stop scrolling. After it's in position, we'll have some sort of credits, maybe put your name down, and scroll those credits from the left-hand side of the screen towards position 1050. After the credits are in position, display the text, press X to start, centered horizontally, and 70 pixels from the top. After the user presses the X key, we'll be transitioning to the game scene where the game will happen. Go ahead and try to do this on your own, and we will be building it together. Alright, so this is somewhat of a longer challenge, so we will go ahead and take it slow. So the first thing that we want to do is separate whether the user is looking at the title screen or whether the user is actually in the game. This means that we need another variable to figure out which state the game is in. Let's go back in our code and we're going to scroll all the way to the top in our init function. We're going to create a new variable called scene. Scene. And let's go ahead and initialize it as the title scene, meaning that the user or the player will start in the title screen. And then we are going to be going inside our update and draw functions and figure out what we need to update or draw depending on whether the player is in the title screen or inside the game screen. For that, I'm simply going to create another conditional if scene, don't forget the double equals. If we're in the title scene, then we're going to proceed to various updates tied to that screen. But if we're in the game scene, we're going to proceed to different updates tied to the game scene. Let's go ahead and take this chunk of code and we're going to copy and paste that inside our draw instruction here. And similarly, if we are inside the title screen, we'll be drawing things related to the title screen, and if not, we'll be drawing things that are related to the game screen. The next thing that we need to do is pretty much move the instructions that we've already written in one of those two states. We currently already have a lot of things moving on the screen, so let's go ahead and look at what we currently have. When we're in the title screen, we definitely want to clear the screen, and we also want to print our title. Let's go ahead and move those two lines inside the first if condition. Note that we'll also want to clear the screen inside the game function. So rather than having a second clear screen instruction here, since we're executing it both inside this condition here and in the else condition, we can simply take it off at the top level. This way we'll be executing this instruction all the time. So once we are inside the game screen, we'll want to draw the background, draw the characters and the clouds and so forth. Let's just go ahead and take this piece of code and put it inside the else part of this conditional. Let's do the same exercise for the update instruction. So here we only want to provide updates to anything tied to the title screen. And right now, the only thing that we're doing there is scrolling the title. So let's go ahead and get this and paste it in place here. Otherwise, all of these other updates are tied to the game itself. So let's go ahead and get this and place it inside the game scene update. All right, so now that we have set that in place, we could start the game. But just as a quick reminder, our title currently starts at -10 from the top unless we're pressing the button. So perhaps we can just get rid of this for now so that the title scrolls automatically without having the user to type or to press a key. Let's go ahead and save and run our game. So this is now the title scene, and as you can see, we don't have anything else being drawn, and this is exactly what we want. We have the title that scrolls by itself, and I don't think it's scrolling down enough, but at least this is, we're only proceeding with the updates and with the draw for the title scene. Let's go back in our code. There's a couple of things that we need to do. First, we need to change the title here. We haven't yet released the first game, so no need to have Showdown 2. This is the vertical position to which the title scrolls, and we're going to update this to 40 pixels so that it comes down from the top. Let's go ahead and run the game, double check that this works properly, and go back to our code. The second requirement that we have for the challenge is to have some sort of credits scroll from the left-hand side of the screen all the way to position 1050. So again, thinking about this requirement, we have additional data in place, which means we're going to need new variables. One variable to store the text for the credit, and since we are scrolling from the left, we will need to store another variable to store the horizontal position, which will change over time. Let's go ahead inside our init function, and we're going to create two new variables. This first variable will be the string of the credits, and the second one will track the horizontal position of our credits. Actually, let's start by 0, and we will see how that will look. So let's go ahead and save, and we of course want to draw the credits. So let's go to our draw call. This is only done when we're inside the title, and we're going to print our credits with the horizontal position of credit X, 50 pixels from the top, and we're going to pick a color, maybe this dark gray here. Let's go ahead and save and run the game. All right, so the credits are currently positioned at 0, which is not ideal, and they're displayed straight from the start, which is not ideal either. So first of all, let's make sure that the credits are being scrolled from the left. One way that we could do this is place the text left of the screen so that when the game starts, the letter S of my name is just right by that border on the left-hand side. And that way we can scroll it similarly to what we did with the title. So if we go back to the initial position of our credits, we want to place this string of text right to the left of the screen. As if you remember, every character is 4 pixels width, so the only thing we need to do is to position this at minus, take the length of the screen and multiply it by 4 pixels. Now we want to make sure that this scrolls from the left to the right after the title has finished scrolling. This is code that should be executed here. So if the title hasn't finished scrolling, then we scroll it, we keep scrolling it. Otherwise, the title has finished scrolling, in which case we will start scrolling our credits. And if we were to run the game right now, this would work well, but we don't have anything to stop the credits from scrolling. And so let's go ahead and create another conditional similar to what we did for the title. We're going to prevent the credits from going too far off, and we're going to limit it to 10 pixels from the left, which I think was the requirements. All right, so let's just reread what is happening here. So once we get inside the update function, we will start by checking the current scene in which we're in. We initiate the scene variable to title, so we'll start in here. Title top will start and be initiated at -10. The title will be off the screen to the top, which means we'll be entering this instruction here. So we'll increase the vertical position of the title by 1, which means we start scrolling the title, and we won't be executing any of the rest. We're going back here all the way until the title has finished scrolling, at which case we start scrolling our credits. And the credits will be scrolling all the way until the X coordinate of the credits will be 10. Let's go ahead and save and run our game. Oh, it looks like I forgot to type in a then instruction here. All right, so you can see the credits are scrolling from the left. It doesn't look quite nice, but I guess we can change that later. So the third requirement that we had was to display some text called press X to start after the credits have finished scrolling. So once again here, we're going to have another else condition to indicate what happens when the credits have finished scrolling. We want to display another string of text, which means we're going to need new variables, both to store the content of this text and also to store the position of the text. We want that text to be centered on the screen, and if you remember, we have gone through that exercise already with Showdown, so this is a little bit of a repeat of what we did with the title. So let's go ahead and create our two variables to store both the string and the positioning. So instructions are going to be press. Something to know is that if you do capital X, it will actually use this nice handy icon here instead of the X key to start. And we are going to position the text. Let's position it outside of the screen for now. So let's do -10, similarly to what we had with the title top. So what happens once the credits have stopped rolling? Well, we need to now position the instruction at the right place, which means that we can just bring it down to where it's supposed to be. And I think the requirement said to put it 70 pixels from the top. All right, so what is happening here? This instruction is going to be printed outside of the screen all the way until the credits have finished rolling, at which point we'll bring them down vertically to the right spot. Let's also figure out the X position so that it's properly centered on the screen. And if you remember, we need to take the halfway point of the screen and remove from that the length of our instruction string, multiplied by 4 pixels for each character and divided by 2 because we want to take the midpoint. So we now have those 3 variables that we can reuse to print our instructions. Let's go ahead and figure out a good color for this. Maybe we can use this dark green here, color 3. All right, so we're always printing the instruction, but because this the y coordinate is -10, you're never going to see that on the screen until the credits have finished rolling, at which point the instructions should be placed at the right spot on the screen. Let's go ahead and save and run our game. Okay, this looks absolutely awful, but it is what the requirements are asking, so let's keep it that way. The only remaining item is that we need to process the user input. Right now, if you type the X key on the keyboard, it doesn't do anything. We just learned that in this lesson, so let's go back inside the code and make some changes in our update method. Right here, so once we're displaying the instruction at the right spot, this is where we want to check for the user input. So let's go ahead and type if button pressed. So if the user presses the X key, then, so what we want to do here is swap the scene completely so that we leave the title scene and move on to the game scene. And so the only thing we need to do to accomplish this is by simply swapping the value of the scene variable to game. Which means that the next time when we go inside the update function, we will just bypass this if condition altogether to go inside this else condition. Let's go ahead and save and run our game. Right now, I can press the X, it won't do anything. But now that the instruction is being given, if I press X, I now move on to the game part. So now that all of the elements are in place to start the gaming experience, it's time to start fleshing out exactly what this game is going to be about. The objective of the action game here is to test out the player's reflexes. And one way that we can do this is to have some sort of timeline that we follow. At first, there is some sort of cooldown period during which none of the cowboys can actually shoot. We will not be looking at whether there is any user input at that point. After 3 seconds, we will let the player know that they can actually shoot. We'll start looking at user input, and if the player shoots, they will win the game. After the 4th second, which means the player has 1 second to shoot before they get shot, we will have the CPU shoot. They will only shoot if they have not been shot by the player between the 3rd and the 4th second. If the CPU shoots before the player will have lost the game. Let's go ahead and build this inside our code. Since we're going to be updating our game quite a bit, it's going to be important to go there right away. Right now, if you run our game, we have this very nice but somehow slow way to start the game. And we only get there after waiting for everything to scroll down. So let's go ahead and go into our code, and rather than starting inside our title scene, we're just going to get started inside our game scene. So that when we go ahead and save and run, we're straight into our game scene. So there's a lot of things that we're going to be putting together right now to complete the game. The first thing that we want to do is we want to create some additional sprites to show the player or the CPU shoot and the player or CPU on the ground after being shot. Let's go ahead and press escape twice and go to our sprite editor. We might use just the next couple of sprites here that are available. Let's start with taking the player. We'll go ahead and select the entire sprite here, move over to sprite number 19, paste it in place, and we are going to just bring the gun up. Oops. We draw the gun right here. All right, this looks about as good as it should be. Let's do the same thing for the CPU sprite. We'll go ahead and select, Command C or Control C, Command V to paste, and we'll just, oops, there we go. All right, so now we have our two sprites for the two players that are shooting each other. Let's go ahead and draw the state when they are on the ground. So maybe we can do something like this. All right, this would be for the first player. And let's go ahead and do the same for the second player. So we'll go ahead and select this, copy, paste it in place. We'll flip it and we will change the color so that they correspond. Let's go ahead and paint the pants or boots and the shirt. All right, so we have our sprites that are all ready to go. Let's go ahead and go back to our code. Okay, so what we want to do is to first prevent the player from shooting until the 3rd second. And then we want to allow the player to shoot the CPU. If the player hasn't shot the CPU after the 4th second, then we allow the CPU to shoot the player. This means that we are going to need 2 additional variables to figure out whether the player has shot or whether the player has been shot. Let's go ahead inside our init instruction. And let's create those 2 variables here. Those 2 instructions, those 2 variables will be booleans. Has shot means that the player has shot the CPU, and was shot means that the CPU has shot the player. Let's go ahead and save, and let's go into our draw scene. I want us to clean this up a little bit. First of all, this text here at the top, we want to draw the sprites regardless. We'll be fixing this in just a little bit. Let's go ahead and remove this for now. Save and run. So our 2 characters are here. The ready, set, go at the top left is not too much of a bad idea, but we just want to show ready at the start and then shoot after the 3rd second, and maybe position it towards the center of the screen. Let's go ahead and change this up. Let's go to the top, and this is the text. The name of the variable is not ideal. Let's call it ready text. And for now, we'll just start by having it read ready. So when we are drawing the game, we are printing the text here currently at the 0, 0 position. Let's go ahead and figure out where to print this text. So first of all, text doesn't exist anymore. It's ready text. And then let's figure out the X position of ready text. Let's create a new variable here, and we will say that this is 64 minus ready text times 4 pixels divided by 2. This is to center it on the screen. By the way, when you multiply by 4 divided by 2, it's equivalent as multiplying by 2. So let's just do this for now. And we will place it at centered on the screen and potentially 10 pixels from the top. So let's go ahead and see. We now have this screen, this title that says ready at the top. And let's make sure that it goes over to shoot after 3 seconds. So let's go into our timer here, and our timer, once it will hit 30 seconds, which is which is 90 ticks, means 3 seconds. We will go ahead and update this to say shoot. Go ahead and save and try this out. So ready. After 3 seconds, it does not seem to update it. Timer plus equals 1. Oh, it's because this is the wrong variable name. All right, so this is working properly. So now, now that we have this instruction, we need to check if the user is actually shooting. So if timer is greater than 90, we don't allow the player to shoot before, and the player has not been shot, so was shot equals false, then here we can listen to whether the player has pressed the button. So if the player has pressed the X button, then has shot equal true. All right, so let's try this out. And what we want to do to make sure that we change the state is, depending on has shot, we can change the sprite that gets drawn here. So here by default, none of the players have shot anything. But if has shot, then, so if the player has shot, what we want to draw is a different set of sprites. So let's go ahead and copy this section here. If the player has shot, we want to draw sprite 19 and 22. Okay, and if the players have not shot, then we want to draw the original sprites. All right, so let's go ahead and try this. So now we should be able to shoot the player after the shoot instruction is gone. So if I press X now, I now have shot the CPU and the CPU has died. So this is good and working so far. There's two enhancements that I want to do. The first one is I find it really hard to know who is who on the screen. So let's go ahead and maybe print out this in the instructions. Maybe just below here we'll print you, and so let's see. So horizontally it's going to be P1X, and vertically let's just put it maybe 10 pixels below the player, and let's put that in yellow, color 10, and let's indicate the CPU right below the CPU sprites. All right, that's a little bit better. It's not just not low enough. So let's go ahead and decrease this to 14. All right, so now if we shoot, we have shot and killed the CPU. So that's a little bit better. One thing I want to do as well is that right now, when we have finished shooting, we shouldn't show the instructions shoot, and we should actually indicate that the player has won. Let's go ahead and add that as well. So if the player has shot, let's print you won rather than the ready text. Let's go ahead and print the ready text whenever the players are just in standby. And here we will print you won, and let's go ahead and print that maybe just right above the player's head. So P1X, and then we're currently at 40, so maybe let's do 30 and use the same color here. Let's try this. So ready and shoot. So now if I press shoot, it will shoot the CPU and indicate that I've won. Yeah, it's not ideal. Not a big fan of that color, and maybe let's just swap it for 10. And also, the string is a little bit long, so maybe we can reduce this by 4 characters. All right, it's a little bit better. We can polish this a little bit later. Okay, so now we need to make it so that the CPU can actually shoot back. Otherwise, it's a little bit unfair for them. Let's go back inside our shooting instruction here. All right, so here what we're saying is if the timer reaches 3 seconds and we haven't been shot, then we can start shooting. What we need to do now is if the timer has gone above, let's say it reaches 20 seconds and we haven't yet shot, then we will make it so that the CPU shoots, which means that was shot will be true. Okay, so we now have the CPU shoot at the player and we need to update the sprites accordingly. So let's go back here, if has shot, then. All right, so here, this else condition here is if the player hasn't shot, and we could here write if the CPU has shot and do similar instructions. So rather than having if and then another if inside the else, one handy way to do this is to actually do else if directly as part of the if condition. So this reads like this: if the player has shot, then we will show the sprites. Otherwise, if the player was shot, then we will execute this block. Otherwise, meaning that none of the previous conditions were met, then we will draw the rest. So here we are going to take this block of code here and just change the sprites that we're actually displaying to indicate that the CPU has won. So the CPU shoots in sprite 20 and the player dies in sprite 21. And of course we will write you lost, maybe bring it down a little bit more. All right, so now let's not shoot and see. So 3 seconds have passed. Oh, it looks like the CPU and the player have swapped spots. Let's just make sure we replace the right sprites and try it again. All right, so there we have it. The game is pretty much complete. We have a winning condition and we have a losing condition. Right now, as you can see, we cannot press the X key anymore. There's nothing we can do as we have died. Let's just make a couple of quick small polish here and there. The U string I want to position a little bit better, and the U lost string I want to position a little bit better as well. So U lost is a little bit too much to the left. Let's increase it a little bit and bring it towards the right. And then the U CPU, let's bring this a little bit closer to the left. Oops. Where do we write? Okay, P1x minus 2. Let's see. Okay, this is a little bit better. Ready, shoot. If we don't shoot, and then we lost. And if we try it again, this time I have 1 second to shoot. I go ahead and I shot and won the game. All right, so there you have it. We have a game that's pretty close to being a pretty complete game with a title screen, a game screen with clear objectives, a winning and a losing condition for the player to enjoy. This is just as simple as we could make the game, and we could probably move on to the next and final video and talk about music and sound effects to polish this a little bit more, and then we could call this game done. However, our game currently lacks one of the absolute most fundamental part of any game. We can't really call our job done until we've tackled that. And that part is making the game fun. As of now, the gameplay is extremely repetitive. It's short, it's predictable. After 3 seconds, we know that we have 1 second to shoot. There's pretty much no reason why anyone would ever play this game twice. And the feelings a player would get from winning are just about as exciting as waking up on Monday morning to go to school or work. So there's a couple of things that we're going to be doing in order to make the game a lot more fun and compelling in the next video. I hope you enjoyed this video and you were able to understand every change that we did. Feel free to make your own changes and make this your own game. I'll see you in the next one.